The concept of robot configurations is slightly more advanced, but very important to understand, especially once the robot goes into production. But here we aren't talking about configurations like speed or acceleration. We're talking about kinematic configurations. We already discussed joint space commands and Cartesian space commands in a separate tutorial. With the move pose command, the robot solves the so-called inverse kinematics and finds different sets of joint positions that all correspond to the same target end effector pose. Each of these solutions is associated with a unique posture and turn configuration parameter. The figure below shows the maximum of 8 robot postures for a given end effector pose. However, since joint 6 can rotate multiple revolutions, each posture can have multiple joint values in increments of 360 degrees. While this is not always an issue, it can become problematic in tight spaces where equipment might be next to the robot. So we need a way to tell the robot which solution to use when calculating the inverse kinematics. In the case of move pose, by default, the robot will choose by itself what solution is the best, and that solution will depend on the robot's starting pose. This is set by using the command setAutoConf1. Although this command is automatically active when the robot is powered on, it's recommended to use it explicitly to ensure consistent and reliable behavior. For instance, if the robot starts from its 0 position and we try to move to this pose using a move pose, we can see that the robot will take this specific path and end up flipped around. Let's start from a different pose and moving again to that target pose using a move pose. We can see the robot choosing a different joint position and trajectory. This detail is important because if the robot is always doing the same thing and starting from the same position by using a few move joints to force it to go to certain positions, there shouldn't be any problem. But if the robot stops in the middle of a sequence because of an e-stop or some other stop and needs to start again, it's possible that the sequence would not be the same, and the robot could take a different path. This is why it's important to specify the configuration of the robot. The reason why there can be up to 8 solutions is because there are 3 configurations. Let's look at the 3 configurations individually. The first is the front-back configuration. It's characterized by the robot's wrist, where axes 4, 5, and 6 intersect, being in front or behind the plane created by axes 1 and 2. The second one is called up, down, and is characterized by the joint 3 angle being higher or lower than -72.43. The last one is called flip, no flip, and is characterized by the joint 5 angle being negative or positive. Knowing how to use the configurations is very important, especially when deploying the system in production. Watch our other video tutorials to learn more about how to make the best of your Mecademic robots.